Welcome to today's video on Cambridge IGCSE Mathematics for the syllabus codes 0607 and 0580. Our topic for today will be mensuration, where we will be looking at the subtopic solid geometry. To begin with, we're going to discuss what volume is. Now, when I deal with 3D shapes, the volume of the 3D shape is the amount of space that there is inside of our shape. So if you're looking at the case of a water bottle, perhaps, or the water tank, then the volume of these would be how much water is required to fill them up. So the amount of water that's required to fill up these 3D shapes is what's called the volume. And when we deal with volumes, we can measure them in metric units, and the metric units that we would be using would always be cubic units. So we could be dealing with cubic centimeters, we could be dealing with cubic meters, or even cubic millimeters. Another conversion that we need to remember is that if we have 1 cubic centimeter, then this corresponds to 1 milliliter. So 1 cubic centimeter is equivalent to 1 milliliter. When we work out the volumes of regular 3D shapes, for example, when you look at this cuboid, the volume of this would be calculated by working out the cross-sectional area and then timesing it by the length that we have. Now, in a cuboid, the cross-sectional area that we could have would be a square, or it's going to be a rectangle. And we can work this out by multiplying the width times the height that we have here. And after we do that, we can multiply that by the length to work out the volume. Similarly, we can do the same thing when we're dealing with a cylinder. Again, we are working out the cross-sectional area first, and then multiplying it by the height. So the cross-sectional area of a cylinder would be pi r squared, which is the area of the circle that we have here. So we're going to do pi r squared and then multiply it by this height to work out the volume of a cylinder. Now, r here is going to be the radius of the circle that we have in the cross-sectional area of our cylinder. We can use that basic principle to actually go ahead and work out the volume of any regular prism that we might have. Now, in this diagram here, we've been shown a triangular prism, which has a triangular cross-section. So to work out the volume of this, what I would do is I would work out the area of this cross-section and then multiply it by the length or by the depth of the shape that we might have. So in this case, because this is a triangle, the area of the cross-section would be half times the base times the perpendicular height. And once I've worked that out, I would multiply it by this length here to work out the volume of this prism. And now this works for any regular prisms that we might have, which has a constant cross-sectional area. If I look at a shape like a pyramid on the other hand, and I can see that for this pyramid, the cross-sectional area is not constant, it's constantly changing. So I have a wider cross-sectional area at the base, and then the cross-sectional area is going to slowly decrease until it tapers off into a point. So when we deal with 3D shapes like a pyramid, we would have to use specific equations to work out the volume. And we need to know these equations as well. So when we're working out the volume of a pyramid, how we can do this is by using this equation. That's 1/3 times the area of our base times the height. We might be dealing with a square base pyramid. Sometimes we might be dealing with a triangular base pyramid. But regardless of the type of pyramid that we're dealing with, we can go ahead and use this equation. That's 1/3 the area of the base times its perpendicular height here. To work out the volume of a cone, what we would be doing is we would be using the equation 1/3 times pi r squared h, where r is the radius of the base that we have, and then h is the perpendicular height. So the volume of a cone is 1/3, again, the area of the base, which is pi r squared, times the height. When we're looking at a sphere, then the equation that we would use for calculating the volume of a sphere would be 4/3 pi r cubed. and this is very important for us to remember as well. So that's 4 by 3 pi r cubed, which would give us the volume of this sphere. So let's work out this question over here. The question tells us that we have a composite shape. A composite shape is basically any shape that has been made by putting or sticking in 2 or more different shapes together. And this is made up of a cuboid and a pyramid on top. What we have to do here is calculate the volume of this shape. So to begin with, let's go ahead and calculate the volume of the cuboid first. Then let's calculate the volume of this pyramid to work out the total volume of this entire shape. So when we want to find the volume of the cuboid, I'm just going to say V. What we need to do is we need to work out the cross-sectional area and then times that by the height of the cuboid that we have. And in this case, I can see that to work out the cross-sectional area, but this specific cuboid, the length and the width are the exact same. So we have a square cross-sectional area. So I'm going to work out the cross-sectional area first. And then I will times this by the height. And because I can see the cross-section is a square, that's just 8 times 8 times the height that we have, that's 10 centimeters. So the volume of this cuboid at the bottom should be 640 cubic centimeters. Next, let's work out the volume of the pyramid that we have on top. The equation that we have for volume of a pyramid is 1/3 times the area of our base times the height that we have. So this is going to be 1/3. And I can see that the base of this pyramid is again a square. So the area of the base would be 8 times 8. And then I would multiply all of that by the height. Okay? And then when I work out the volume of this pyramid, that's 1/3 times 8 times 8 times 6. We're going to work out this to be 128 cubic centimeters. Then to work out the total volume of the shape, so the total would be 640 cubic centimeters plus 128 cubic centimeters, which is going to give us a final answer of 768 cubic centimeters. So that's how we would approach this question. Let's also have a look at an exam type question here. And this question reads, find the volume of a hemisphere with a diameter of 36 centimeters. Now, a hemisphere is essentially half of a sphere. So what we're going to do is we're going to first find out the volume of a sphere that has a diameter of 36 centimeters. And then we're going to divide that by 2 to work out the volume of a particular hemisphere. When we deal with the volume of a sphere, so the volume of a sphere has the equation 4/3 pi r cubed, where r here is the radius of our sphere. We have not been given the radius, so we need to first work this out. The radius of something would basically be the diameter, but halved. So 36 divided by 2, that's going to give us the value of the radius. And for this particular question, the radius is going to be 18 centimeters. So if I work out the volume of a sphere which has a radius of 18 centimeters, that's going to be 4/3 times pi times 18 cubed. And we can use a calculator to work this out. And what we're going to get is going to be 7,776 pi. So in terms of pi, this is going to be 7,776 pi cubic centimeters. So this is the volume of the specific sphere that we have. And now to convert this into the volume of our hemisphere, I will just take this entire thing and divide this by 2 to work out the volume of our hemisphere. And when we do this, we're going to get 3,888 pi cubic centimeters. Now, this is in terms of pi. We can also calculate what this would be as a decimal answer. And that's going to give us 12,214.51 cubic centimeters, correct, to 2 decimal places. So there we go. This is going to be our final answer. So that's it we have for solid geometry. Thank you.